Please go to elithecomputerguy.com and failednormal.com to see the videos that are too dangerous for YouTube. Welcome back. So in today's video, we're going to use an Arduino Uno with Wi-Fi board and an analog temperature sensor to create a temperature sensor that is accessible through a web browser. So let's say you want to create a temperature sensor. You want to be able to see what the temperature is in a server room, in your basement. Just basically, you want an internet accessible temperature sensor. The project today will allow you to do that. So we're basically going to combine these two. We're just going to take an analog temperature sensor. We're going to take the Arduino Uno board with Wi-Fi. We're going to add a little bit of code, and then we are going to be able to access this board from a standard IP4 internet address, and then we will be able to see what the temperature is from a web browser, whether it's Safari or Internet Explorer or Chrome or whatever else. So with that, let's go over to Workbench to show you the components and how to build this project. Then we'll show you the code and how it works. So you don't need a whole lot for this particular project. We have the Arduino Uno Wi-Fi board. We have our analog temperature sensor. We have our breadboard, and we have a couple of jumper wires. That is all we're going to need for this particular project. Simply slot the analog temperature sensor into the breadboard. Again, when you're looking at the analog temperature sensor, the left side is positive, the right side is ground, and the center is the sensor pin. Do make sure you get this correct or you will burn out your temperature sensor. That's why you should always buy Arduino components by the dozen. Then what we're going to do is we're just simply going to plug ground into ground. We're going to plug positive into the 5 volt, and then for this particular project we are going to plug the sensor pin into a 0 because that's what we have in the code. Now, one thing for this project, just so you know, is I did actually have to pull out my multimeter. Woohoo! I had to pull out some of those old electronic repair technician skills because when I did this project and we were reading the temperature sensor from the sensor, the temperature was about 5 degrees warmer than it should be. And so I had to go through and troubleshoot why that is. And what I found the problem to be is this particular board. I don't know if it's this particular board as in this specific one, or it may be something with the Wi-Fi boards in general. But when I connect to the 5 volt power pin on this Arduino board, I only get about 4.85 volts. So when I take my standard Arduino board and I connect to the 5 volt power pin, I get 4.997 volts. So close enough to 5 volts as far as our projects are concerned. With this particular board, we actually don't get a full 5 volts. Again, we only got like what I read was about 4.85 volts. And because of that, remember all the temperature readings and everything is based off of voltage. So if we're not getting the full amount of voltage out of the 5 volt, then the readings that we get back will be different than what they should be, and then the temperature will be different than it should be because all the temperature is based off of the voltage being put through an equation. So this is just something to keep in mind, especially if you're going to be doing Wi-Fi based projects, and especially if you're going to have multiple of these projects, is make sure to calibrate your board and your sensor and your project to make sure it's giving the readings that it's supposed to. So in this particular case, since this project gives me temperature that's about 5 degrees, somewhere between 4 to 5 degrees higher than it should be, I might simply go in and when I create the temperature Fahrenheit variable, I may simply subtract 5 from that in order to get that variable. And so this is something that you should be thinking about. If for some reason you're not getting the proper voltages or things aren't coming through to give you the exact number that you're supposed to be getting, you should be thinking about when you're dealing with a sketch, should you add 5 here, should you subtract 5 there, so on and so forth. But that's just something to keep in mind. I'm not sure if it's the board in general, as in all boards would be this way, or this specific board, but this specific board on the 5 volt pin is only giving out 4.85 or so volts, which does cause an issue for the actual reading for the temperature sensor. Other than that, it simply shows us a temperature that's about 5 degrees warmer than it should be. Otherwise, everything works how it should. So this is just something to keep in mind. Now with this, again, if you're going to be powering this, do remember Since it's going to be Wi-Fi, and since you're going to be accessing over the Wi-Fi, you can take something like a USB battery pack, or you can use an external power adapter to power this particular project. So again, that's one thing to realize with this kind of project here. So you could have this completely separated from any kind of computer, and you can still access it over your wireless network because it has that Wi-Fi component. So with that, let's go over to the sketch to show you how to code for this thing. So here's a sketch for this project, and like many of our projects, I've basically just combined two projects we've previously done. So I've combined the basic Arduino Uno with Wi-Fi board setup video that we did previously, and I've combined our analog temperature sensor projects that we've done previously. So with this, in order for this thing to be able to communicate over the Wi-Fi, we're going to need to include two libraries. So we're going to include the SPI.H library and the Wi-Fi 9 library. So the first things we're going to do is include those libraries. Past that, we're going to have to define the sensor pin. So where is the data going to be coming from that analog temperature sensor pin? And so we're going to define, we're going to call it sensor pin, and we're going to connect it to analog 0, A0. Then we're going to come down, we're going to give the information that's required in order to connect to our Wi-Fi network. So char SSID equals, and so I have a guest network that I've simply called test. Char pass, so this would be the password for your Wi-Fi network. I have left it blank just to make my life easier. And then an int key index. If you're using a Wi-Fi network with multiple keys, this is where you would give the number for the key index that you're using. Since we're not using any passwords, that doesn't matter for us. The next thing that we're going to do is we create an int status variable, and we set the value to that to WL idle status. So this just simply says we're creating a status for our wireless network, and we're starting it with it being idle. Then we're going to do the Wi-Fi server, and we're going to set the server to port 80. So if you wanted to use a different port for some reason, you could set that here. We are using port 80 because that's just simply the standard HTTP port. So that's the first component of the sketch that you're going to have to type out. Then past that, the first thing that we're going to do is serial.begin 9600. So this starts the serial monitor so we can see what is going on with the Arduino board. Then the next thing that we're going to do is we are actually going to try to connect to the Wi-Fi network. So this is a while loop. While status is not equal to wireless link connected. So while it's not connected, serial.print attempting to connect. So this will simply print out to the serial monitor. Serial.print SSID. So this will print out the SSID. So that will print out test. Then status equals Wi-Fi.begin SSID password. So this is the function that actually tries to connect you to the Wi-Fi network. So it'll feed it the SSID and the password, and if that works, you should connect. And then this delays for 10,000 milliseconds or 10 seconds because it's a while loop and you don't want to be hammering the Wi-Fi network too hard. Once you break out of that while loop, so once the status is connected, then you're going to break out, and then you're going to do server.begin. So this starts the server service on the Arduino Uno Wi-Fi board. At that point, we're going to print out to the serial monitor, basically to say we're connected to the network. We're going to print out SSID, then we will print out what the SSID is. We're going to set a variable for the IP address, which is the Wi-Fi.local IP. Then we're going to serial print IP address, and then we will print out the value of the IP address. This is very important here because, again, unless you hard code the IP address for your little Arduino device, you need to know what the hell the IP address is. If you're going to go to an IP address, you need to know what it is. So you either need to hard code the IP address into your Arduino device, or you need some way to be able to tell yourself that. So whether it's an LCD screen that prints it out, or whether you print it out on a serial monitor, you need some way to know what the hell the IP address is of your Arduino. Then past that, we're just simply going to go down and we're going to go into the loop. And again, this is where we cut and paste sketches, previous sketches that we've done. The first thing that we need is the way that we're able to gather or collect the actual temperature sensors. So this is the analog temperature algorithms and stuff that we normally do. So we do int, so we have a variable int reading equals analog read. So this reads from the sensor pin. And this is where I'm telling you, for this particular board, this reading is wrong. Well, it's not that the reading's wrong. The reading's right, but because of the voltage, it's not what what it's supposed to be. And so this is where, again, like I say, in this math, you may want to go in and plus or minus or something in here if you need to tweak this. Then we create the voltage, then we divide the voltage by 1024, then set it. Then we have the float for temperature C. So this gives us what the temperature in Celsius is. Then in order to get the temperature in Fahrenheit, we have this here. And so basically all this does here is you copy and paste this, and this gives you the temperature so you can print out that value. Then we come down here, and this is the Wi-Fi connection. So this is how we actually send data to the web browser that is connecting to the Arduino. Again, remember, in the technology world, you actually have to explain how all of this works. And this code here is what does that. So Wi-Fi client equals server available. So this makes a server available. If there's a client, print line. So this is serial print line. So this will print in the serial monitor, new client. Then we have a string, current line equals basically nothing, while client is connected. If client is available, char character C equals client read. And so what's going to happen here is basically it's going to go through. So when your web browser connects to the Arduino, your web browser actually sends the Arduino information. So what the Arduino is going to do is it's going to parse that information literally character by character, because it needs to know when to send information back to your browser. So it's going to parse character by character. And what's going to happen is when it detects a new line that is blank, so basically when it finds a new line, and if the current line length equals blank, so if there's nothing there, then it's going to print out to the client. So basically what it's doing is it's parsing character by character by character by character. It comes to a new line, and then if the new line is blank, then it sends information to the client. If the new line has information, then it keeps waiting, waiting, waiting. And then the rest of this down here is part of that function. So the main thing that we're worried about is this little section right in here. So if it gets to a new line and the new line is blank, then it's able to send something to the web browser. So client.print, so we're going to print to the client, client.print, and we're going to print out temperature, space, and then client.println is temperature F. So to be clear here, all I'm doing is printing out in basic ASCII text. Now, so again, since we're printing to a web browser, something to think about is you can format with HTML. I could format this with H1 tags and bolds or strongs or colors or other things. With this, since this is a simple project, all I want to show you is that it can print out text and the value of a variable, and that will show you what the temperature the analog sensor is reading. So that's why we're doing this here. Again, we could have HTML text and all kinds of other stuff here, or tags, but I'm just doing this to be simple. Then we go through, we finish the rest of that part of the if else, then we do client stop. So once we've printed to the client, we actually need to stop that connection. Then we do serial.println, so we're printing to the serial monitor, client disconnected. So with that, then we connect this to, we connect our Arduino board to this. We upload the sketch, and then we should be able to read what the temperature is from the web browser. So here I am connecting our little Arduino project to the computer. So this will give it power, and we'll be able to upload our sketch. I'll simply upload our sketch. Again, when you're doing this, do make sure to go to Tools, Board, and make sure you've selected the right board. So this is the Arduino Uno WiFi Rev 2. Again, if you're using multiple boards, it's very easy to stay on the Arduino Uno when you try to upload, and it will fail. So do make sure you select the right board. Then once it's been uploaded, we can go to Tools, we can go to Serial Monitor, and then this is where we have attempting to connect to network name, the SSID. So it's test. Should take about 10 seconds for this to be connected to the network. And then we have, so we have our SSID equals test, and we have our IP address 172.16.42.5. So what we can do is we can take that IP address, we can go to our web browser, and so I already have this plugged in. We can hit refresh. And woohoo, look at that. Oops. The temperature is 72 degrees. So we have temperature here. So we have temperature. So that's the text that gets printed out, and then the value of the variable for temperature is 72 degrees. Now, one of the things to realize though is, you have to be thinking about how things refresh. And so when I touch the temperature sensor here, the temperature for this temperature sensor is going up, but you'll notice that the temperature on this web page doesn't go up. And the reason is because the web page doesn't auto refresh. So if you want to see what the current temperature is, you hit the refresh, and then when you refresh it, it's then up to 86 degrees. And you refresh it again, now it's up to 87 degrees. I take my finger off, and so the temperature should start cooling, the sensor should start cooling, and as we can see, it goes down to 83 degrees. And so again, this is one of those things you have to be thinking about with your coding. You have to think about things such as, how is the variable going to refresh? Is it automatic? So like in the serial monitor, we simply have a delay, and then that delay delays how often things get refreshed, but it gets refreshed automatically. Or if you come to something like a web page, one of the questions you're going to have to ask yourself is, how are you going to refresh something like this temperature sensor? Because think about it for a second, right? Let's say you do all this, you create the temperature sensor, and then you put this on some kind of screen in your office or in your computer lab. Well, if it's simply static, so it takes the temperature that it was at the moment in time you loaded the page, and then it doesn't change, then that might not actually be that valuable to you, because the temperature may have changed quite dramatically. So something that you need to be thinking about is, do you want to add like a browser plugin to auto refresh the web page every minute, 30 seconds, whatever else? Or do you want to add some kind of script into the web page so that the web page itself auto refreshes itself? Now how you do that and why you do that, it would be situational. In some situations, you would want the page to just simply auto refresh itself. In other situations, you would want to be able to control that, again, maybe through a browser extension, something like that. But that is one of the things that you have to think about. So there we go. Like I said, it's temperature 72.96. If we go over here to the Arduino, this is the serial monitor, and this shows us the information about the client that's connecting to it. So host 172.16.42.5, max age, user age in Mozilla, and some of this other information here, so you can have an idea of the computer that's connecting to this Arduino project. And that's really all there is to this. We just have a little analog sensor connected to the Wi-Fi. Then we're able to go and access it over again, just a standard IP-based network, and take a look at it in our web browser. So that's the basic project. We use the Arduino Uno with Wi-Fi, we use an analog temperature sensor, and now we're able to see what the temperature is from anywhere in the world using a simple web browser. Obviously, you have to add some port forwarding and other things that might be involved if you're trying to access this from the outside world, but this is the basic idea. Again, this has a standard IP4 IP address. You have port 80, and then all you do is you're able to open up the interface using a web browser and see whatever you've coded it to see. Now the cool part is, as we start to create more complicated projects, is that you can have more sensors connected to a single Arduino board, so you're going to be pulling a lot of different information in. Or again, one of the things we're going to be doing in the future is we can create hyperlinks to do things such as turn on fans. So just like we've created systems in the past to automatically turn on fans if a temperature gets too hot, one of the projects that we'll do is we'll be alerted that the temperature is too hot, and then we can manually turn on the fan or manually turn off the fan. Again, that will show you how through a Wi-Fi connection you can turn on and turn off motors. Again, whether that's a fan, whether that's a water pump, whether that's some kind of compressor or something else, basically any kind of motor-driven device you can turn on and turn off simply by using a web browser, going to an IP address, and being able to interact with the Arduino board. So that's all there is for this particular project. Again, with this particular project, I did notice my 5-volt connection here is only putting out 4.85 volts. So as far as the temperature is concerned on here, if I was going to put this into a production environment, I would probably go into that basic temperature math, and I would just add 5 in one of the locations. But that is something that you're going to have to think about, because again, like if you're putting multiple temperature sensors around your environment and you're trying to analyze and see how the temperature reacts in different areas, the first thing that you need to do is make sure that they all have the same baseline reading. The temperature here, make sure the temperature here, if you have all 5 of them, let's say, make sure they're reading all the same temperature before you deploy them to wherever they're going to go. Because if one is reading 2 degrees too high, and another is reading 3 degrees too low, and another is reading accurate, and then you put those out into the real world without trying to modify things, tweak things to make them have the same baseline, then the numbers that you're going to get are going to be garbage. How do you know if the temperatures or the readings that you're getting show something, or if the temperature and readings that you're getting are simply incorrect and therefore they're pretty useless? So just one of those things to remember. Again, if you're going to be dealing with Arduino, I would suggest you go out and pick up a multimeter for issues like this. Again, this is a very simple way. You can just plug this into the 5-volt connection and see, is 5 volts actually 5 volts? One of the most important things in technology, one of the most important lessons I can ever teach you in technology. Are you receiving the results you're supposed to be receiving? So much troubleshooting can be solved by simply plugging in a multimeter or doing something else and making sure if it says 5 volts that you're actually getting 5 volts. Because if you're not actually getting 5 volts, then all the other troubleshooting that you're going to do is basically just a waste of time, because the problem is you're not getting what you think you should be getting. So anyways, with that, as always, I enjoyed doing this video and I look forward to seeing you at the next one.